Good morning, good afternoon, and good evening, everybody. Welcome to today's very special webinar on a very special topic. Thank you for taking the time to join us. My name is Amol, and I will be your moderator for today's session, together with our speaker, Yanano. As we know, corrosion remains one of the biggest challenges across chemical and industrial environments. In many cases, the issue is not only operations or maintenance, but selecting the right material for the right process conditions. The composite solutions such as FRP and dual laminate systems have been widely used in the industry for decades, yet many engineers and plant operators still face questions around where those solutions make sense, what their limitations are, and how to select the right approach. That is exactly what today's session is about. Our goal today is not to make this as a sales presentation, but a practical engineering discussions focus on real applications, decision making, and the lessons learned from the field for many years. We will also have an interactive discussion so that we will not feel alone. And towards the end, I will also have question and answer with our speaker, Yanano, so that you get an opportunity to talk to him as well. Before we begin, some practical notes. All of you are on listening mode only. You can see there are certain people, so we just want that we are more effective offering this webinar. If any questions, please feel free to use question and answer session. You can see it on the top. And we will discuss and address as many questions possible. If we couldn't, we'll ensure that we will get in touch with you on the email and answer them. Now I would like to introduce our today's speaker, Mr. Jan Arno van der Laan, sales manager at Greatech with immense amount of experience in composite tanks, piping system, and corrosive material in an industrial application. Jan Arno, are you ready?
I'm ready, Amol. Thank you. Thank you for the introduction. Good afternoon, evening, morning, everybody. Great to see you all attending to this webinar. First, a short introduction to Greatech. Greatech works closely together with the several specialist partners. Polyplast is a full GFP and dual laminate producer of tanks, scrubbers, apparatus, piping, and is located in India. UNP Valves, specialized in steel PFA aligned valves and TFE aligned steel tanks and piping, also based in India. Rotec, a Dutch GFP producer of pipes, nozzles, manholes, backing rings up to a diameter of 3000 millimeters, 3 meters. So that is Greatech. Now a few words about myself. My name is Jan Arno van der Laan, and since November 87, I've been active in the GFP tank, scrubber, apparatus, and piping industry. I've worked with Plasticon, Polem, MIP, Composite, and I have extensive experience in both of shop and field fabrication. Okay, what will we discuss during this webinar? Today I will give you some basic information about the different types of material, resins and liners, how to select the right material, advantage and disadvantage, and the design standards. But before we start talking about GFP and FRP, I have a question for you. What is the main reason why steel and stainless steel fails in the chemical process in the installations?
So just to help Jan Arno, we have decided to have a quick quiz where you could also participate, and we can kick off. What is the main reason steel can fail unexpectedly in chemical processing installation? And you can see option A, B, C, D on your screen. You can submit. All right. 7 responses. Janano, I see there are some responses, and all of them have answered corrosion caused by chemicals.
Well, that's the right answer. So all good to know. And this is also where this webinar is about. So why the traditional materials fails? We can go to the next slide. Yeah, and can you remove the quiz?
Yes, it's already done. You can
Okay.
remove it from your screen.
Okay. Does this picture look familiar to you? Well, traditional materials often fails because of corrosion caused by acids, chlorides, caustics, and mic. In many cases, the selected materials is simply not resistant enough to the processed liquid. Other common issues are poor welding quality or post-treatments, problem with rubber linings, difficulties with on-site lining applications. Shop fabricated tanks are generally easier to control in terms of quality. However, applying rubber lining on site remains a very serious challenge. Because there are limited alternatives in the past, rubber lining has been used for many years. So what is the alternative? Let's take a closer look at composite solutions. The advantage and disadvantage of composites. The advantages are excellent chemical resistance, no corrosion, lower weight, long service lifetime, and proven technology. The disadvantage, relative young material compared to steel. It's in use since the 50s. And the maximum design temperature is for 120 degrees C for liquids and 160 degrees C for gases. We are talking about GRP, FRP, and GRE. What is the difference? So actually, GRP and FRP are essentially the same material. Glass fiber reinforced polyester or vinyl ester and fiber reinforced polyester vinyl ester. GRE stands for glass reinforced epoxy. These materials are a combination of resin and glass fibers. There are different types of polyester resins. For example, orthophthalic resins and isophthalic resins. These are typically used for low chemical loads and temperatures up to approximately maximum temperature of 60 degrees C. Vinyl esters are also available in several grades. The main difference are the chemical resistance and the temperature capability. Vinyl esters offers a significant better chemical resistance and can be used at temperatures up to 160 degrees C for gases. Glass fiber reinforced epoxy is widely used for firefighting systems and offshore applications. In terms of pricing, vinyl ester resins are more expensive than ortho and isophthalic resins. Epoxy resins are generally more expensive than the vinyl ester resins. For making a laminate, we need resin and glass. And we have different glass types for the reinforcing. The shopstrand glass, for example, provides strength in all directions. Woven rovings provide higher strength in two directions. Winding rovings provide strength mainly in one direction, is often used for cylindrical products. And on the right side below, you see the veils. They're used to create a high quality chemical barrier and a smooth exterior surface while also protecting against environmental influences. The structure and the reinforcement. The chemical barrier of a full GRP product typical has a thickness of, let's say, 2.5 to 5 millimeter and consists resin and glass. In dual laminate constructions, the chemical barrier is made from a thermoplastic material. The reinforcement structure provides the mechanical strength and can be built up using different laminate configurations depending on the application. How do we select the right material? Well, the material selection depends on the chemicals we want to store and the design temperature. It's always this combination. Resin and thermoplastic suppliers can provide guidance for selecting the correct resin or liner materials. According to the design standard, we must stay at least 20 degrees C below the HDT. The HDT is the heat deflection temperature of the resin. Above this temperature, the resin starts to lose strength. So typical maximum design temperatures for composite products, piping and tanks are 110 degrees C for full FOP in combination, for example, with brine, and 120 degrees C for special dual laminate constructions. For even higher temperature, combined with highly corrosive liquids, PTFE or PFA lined steel can be suitable alternative. To give you a better idea of the production process, we will now show a short polyplast video. So this is the factory, the gate, which you can see. Of course, we have our own in-house engineering department, stress analysis, winding machine. Here you see the winding rovings going through a bath with resin. And so you can see, and of course, machining the flanges if needed. And we have our own quality department and can do all kinds of destructive tests. And this is the new building, which will be opened very soon. The production process. Okay, you saw already on the video the winding process. But for full FOP products, we need a smooth mold to achieve a high quality surface finish on the inside. So the process starts first with a 100% resin layer of approximately 100 microns. After the resin layer, one or two fail layers combined with resin. And after these two layers, several shop strand mat layers, depending on the required thickness of the chemical barrier. The chemical barrier itself is not included in the structural strength calculation. The reinforcement layer for cylinder bottoms and roofs consists of different laminate structures with different mechanical properties. The laminate design can be optimized depending on the application. For example, higher or lower axial or tangential strength. For example, if you have a pressure vessel, the strength ratio between the tangential and the axial direction must be 2:1. This is completely different if you compare it to, for example, a steel product. For dual laminate products, the chemical barrier is provided by the thermoplastic liner. For example, for PVC liners, roof and bottoms can be formed using heat and vacuum molding. The PVC sheet is heated in an oven and vacuum formed into the mold. The reinforcement is bonded by grinding the surface and applying the correct bonding resin. For other thermoplastics, the liner material is supplied with the backing material, such as glass or a synthetic fabric. Roofs and bottoms are produced in segments and reinforced with laminate. For quality control purpose, welds are covered with carbon veil so spark testing can be performed. Once the body is completed, nozzles and accessories are insulated and connected using reinforced laminates. Okay, then we go to the design standards. The design of a tank, scrub apparatus and piping is based on international standards. For tank scrubber and apparatus, we use the European standard, that's the EN 13121, or the American standard, the ASME ATP1. Nowadays, more and more use of the EN is taken in account because it's not so comfort. How do you call it? I come back on this one. The main differences between the standards is the way the overall safety factor is determined. For example, for the EN 13121, the basic safety factor is 1.9, and then we have to multiply the basic factor by several factors. It's an A1 till A5. A1 is tolerance of the mechanical properties. A2 has to do with the chemical environment. A3 is the temperature versus the HDT. The A4 is manufacturing factor, and the A5 is the type of laminate. The total safety factor must exceed 6. For the ASME ATP1, the overall safety factor is 10, so much more conservative. For piping systems, additional standard apply and stress analysis is essential. About the quality control, everything starts with the proper quality inspection plan. The laminate thickness must be comply with the static design calculations, and the laminate must meet the required mechanical properties. That's complete different as we compare it to steel, because you have certified plates. And what we are doing, we have to produce our material every time again by the combination of glass and resin. Examples of application. And now you understand how the products are made. Let me show you some samples. For example, acid tanks made from 100% vinyl ester resin. Scrubbers made from 100% vinyl ester resin. Dual laminate tanks and materials for example, ECTFE FRP products for high temperature and highly aggressive environment. Okay, the conclusion is to achieve the expected lifetime and service time, it's extremely important to ensure a correct material selection, the proper design, production by qualified personnel throughout quality control. Okay, that concludes my presentation. Are there any questions?
Thank you. Yeah, no, that was a great sprint, quick discussions, knowing a lot about this particular area. For our attendees, if you have any questions, please use question and answer chat functions on the top so we can take some of them. And in the meantime, Jan and I also prepared some questions for more interaction and discussions. Is GRP water resistance, by the way?
Water resistant, yes, it is. As you probably know, it is the material can absorb liquid, and especially for water application and for higher temperatures, it's better to use vinyl ester resins instead of isophthalic resins, for example.
Okay, thank you. And what is the maximum design pressure and temperature? There's a question from one of the audience member.
Sorry?
What is the maximum design pressure and temperature for this material?
Well, if we talk about piping, it depends also about the size, but normally we can go up to, the smaller diameters can go up to 25 to 40 bars. If the diameters gets bigger, let's say DN600, we can go to 16 bar. If you look to pressure vessels, then also the size is important, but then we have to work with other type of heads. For example, a 3-meter diameter tank, you can be designed up to a pressure of 10 bar, but I think that's at the end the maximum.
Thank you. And can full GRP be provided with an electrically conductive inner and outer layer?
Yes, because to get a conductive layer on the inside, we are able to add nano tubes into the resin, and this will give a very good electrical conductive layer on the inside. So, for example, we did it in the past for fuel additives with a very low flash point. These tanks has to be foreseen with a conductive layer on the inside. So, and of course that you can make connection with outer world to get rid of static electricity.
So interesting. Thanks, Yana. So there is one question that everybody will have from the audience, or if you go to outside of all the industries. Is this a cost-effective solution when it comes to steel equipment versus composite? And when does it make really sense to go over composite compared to steel?
Well, it depends all on the type of chemicals, but if you talk about chlorides, especially at higher temperatures, then composites are they don't have any problems with chloride. Brines and composites are the best friends, so there is not an issue at all. But also with hydrochloric acids, sulfuric acid at higher temperatures, well, all kind of acids can be a serious issue in combination with stainless and of course with steel. So in that case, the composite products and the dual laminate products perform much better.
All right, thank you. Since the when it comes to caustic, it's an interesting chemical, and there's always a question: which type of material is recommended for caustic?
Well, there are in the world are some there are a few options. You can do it in full FOP and especially in the United States they use a synthetic veil on the inside, a nexus veil. So you make actually a full yeah. Full plastic inside of the tank of the pipe, but to my opinion, the best solution for caustics are a PP liner, polypropylene liner on the inside. But because I have seen too much failures with full FOP products in combination with caustic, especially with potassium hydroxide. It's much more aggressive than sodium hydroxide. But yeah, to my opinion, you have to go for the dual laminate version and then the PP application.
Okay, perfect. Now you can just give me answer yes or no. Can FR be used in the food industry?
Yes. Yes.
What about seawater applications?
Yeah, it's very good because of the chlorides. It's very good to go back to the food applications. And at this moment, there is an issue with, especially in Europe, with the bisphenol A. So, but at the moment there are resins, also vinyl resins without BPA, bisphenol A components. And so then they are widely used in food application, especially if there are also corrosion issues. So not in the world of the diaries and that kind of things, but for example, Kikkoman. If you look to the Kikkoman, the soy sauce tanks, the soy sauce production, they have only fiberglass tanks.
Okay. And when it comes to seawater, what kind of equipment like chimneys, pipes, ships?
No,
Yachts? Is it possible?
yeah, seawater. You know, the desalination installations are all made of composite material, piping, cooling water intake. So that is the perfect solution.
Okay. There's another question from the audience. By the way, all our professional audience, if you have more questions and interesting subject, please feel free to add it on the chat or question and answer. We would love to utilize this time to get more and more questions from Yanano. So there's another thing, another question I saw. What about the working fluid? If it contains some abrasive, do you think will FRP work there?
If you have an abrasive liquid.
Yeah.
Yeah, but the material itself is not very it's not abrasive resistant, but especially for mixing tanks, but also for piping. In the mining industry, we add silicon carbide into the resin. Let's say between the 15 and the 25% weight percent. And that gives a very good abrasion resistant liner on the inside. And there are already a lot of mining companies that have the experience with this solution.
Okay, interesting.
Even at high temperatures, in the combination of sulfuric acid and for leach processing. At temperatures up to 85 to 95 degrees C.
All right. So one practical, maybe cost related question. We showed that video, and maybe a lot of audience will have question how cost effective it is to produce it in India and get it to Europe. Of course, you already have a lot of references. What do you think? And this is a common question. For sure, you get this question every day. How cost effective?
Yeah. We have to do we have the transport costs, but
Mhm.
which has an influence on the price. But
Mhm.
still, it makes it very interesting to look also to the Indian producers, especially for the products which are able to produce on flat racks or in containers, of course. And for all kind of products with more labor, so
Mhm.
labor intensive products, and piping for sure, because it's easy to transport, and that's what we see, that piping material is very interesting. But again, also tanks and apparatus. Dual laminate tanks are more interesting than the full FOP products.
All right.
Because there are also more producers who are able to produce this full FOP products.
Okay. Thanks. I was looking at your slides, and when we talk about advantages and disadvantages of rubber lining, I think it's good to really explain it in more detail because I think it went too fast. What are real advantages? Why should people think of rubber lining option when they're still working? A lot of other solutions available.
Well, if a rubber lining can work, but as soon as it comes behind the rubber lining, and there is a small hole or whatever, you will have a problem, because the rubber is resistant, but the steel is not resistant. So you will directly have an issue, a corrosion issue, behind the rubber lining. And for difficult products, it's also hard to add the lining and to the steel products. So that makes it very hard. And what we also see is that, especially for field fabricated tanks, for example, in a lot of cases it was the only solution to use in the past, to use rubber lining, because there was not an alternative. For example, for hydrochloric acid, it's impossible to store it in steel or stainless, so you have to do something. But still, after, let's say, 8 to 9 years, they will get a lot of maintenance every years, every 2 years, because of small holes, small leakings, and that will destroy directly the steel part. So the steel will corrode directly behind the liner.
All right. And when do you say no to rubber line? Like, what are your experiences when you go to the client, you receive RFQ, or there are a lot of discussion, and you say, no, please do not touch rubber lining in these cases?
Yeah, now what we see more and more, that people are not asking anymore for rubber linings. They want to go for a good solution, and then they go for a dual laminate or a full FOP solution.
Mm.
And then depends on again on the temperature and the type of chemicals. If we have to go for dual laminate, or if we have to go for a full FOP application.
Mm.
For example, if you talk about demi water, the mineralized water,
Mhm.
it's also pretty aggressive to stainless. We can do it in full FOP, and but in full FOP, especially with fine lasers, you can get some blistering. But a very good alternative is then to use a PP liner.
Mhm.
So maybe a little bit more expensive, but it will have a much longer service time.
All right. All right. Interesting. Can you tell us a little bit more about those really aggressive acids, hydrochloric, sulfuric, and so on? What is your experience? How people should select? What are the design consideration and so on? Because
Well, especially for the sulfuric acid, for example, at the lower concentrations. Again, if you look to the leach processes in the mining industry, for example, copper,
Mhm.
they use a 50% sulfuric acid solution. Um, that's perfect to use a full FOP product. Final ester liner, final ester reinforcement. That's perfect solution. Excuse me. If you go to high concentrations, up to 70-80%, it's doable at low temperatures in full FOP, but above the 80 degrees C, you have to go to a dual laminate solutions, and till 96%, you can use PVC liner, and above the 96%, so you have to use ECTV. And the PVC liner is only possible if you go to a design temperature of, let's say, 40 degrees C. With
Okay.
hydrochloric acid, it's actually the same. With PVC liners, they have if you use it for storage tank at low temperatures. PVC liners have a very good track record. Normally, the lifetime of this kind of tanks, if they are proper made, the lifetime will be, let's say, between the 30 and the 35 years.
Okay.
But there is also experience with full FOP, and the lifetime will be a little bit shorter, up to 25, maybe between the 25 and the 30 years. Depends also on the quality of the product.
Okay. Somebody asked question about sulfuric acid concentration more than 90%. You mentioned 80 and above, so I think it's the same answer. Doesn't matter, it's more than 90%.
So it's not doable in full FOP. You have to choose for a liner. But PVC is possible, but then the maximum concentration is 96. If you go above the 96, then you have to go for another liner material, for example, PFA or ECTV.
Okay. Thanks. So let's say Yarno customer comes to you and mention that he wants to purchase 30 meter cube hydrochloric acid tank. Okay.
Yeah.
What is the order process? How does it start in terms of drawing, next step? How does really we come to the conclusion and the proposal stage?
That's always what we have to know is design temperature and pressure. Normally it's atmospherical design temperature pressure, but that's something we have to know. So temperature, the concentration of the liquid, and then the number of nozzles. Is it the flat bottom tank with the conical bottom, or the dish bottom, horizontal? That's all what we have to know. The number of nozzles, manholes. Do you want to have a cage ladder, railing on top or not, etc., etc. So based on that information, we can make a quote. And also based on that information, we'll try to give our clients the best advice.
Okay, interesting. So you showed some case histories. Of course, as far as I know, there are a lot of other material or equipment Grade can supply. What about chimneys, mixers, ducting, headers with GRP? Is it also possible with Grade? And if yes, is it complicated to supply all these things?
No. Especially if you talk about the headers, it's in most of the cases, the diameters are very good transportable, so that's not an issue. Chimneys, if you want to have a chimney in one piece with a length of let's say I don't know, 40 or 50 meters, it's a little bit more a challenge. But then we have also possibilities to connect the pieces together, because chimneys with the length of or height of 40 or 50 meters will not be transported in one piece normally. So we have to laminate them together, and that kind of side work can be done.
Perfect. So when it comes to composite material, a lot of people talk about HDPE and not going for GRP. So I'm sure you have come across with questions, oh, why not HDPE, or what is the difference between two, and when to select HDPE, not GRP? What is your experience?
Polyethylene, the high density polyethylene is a perfect material if you use it at low temperatures, and for example for flat bottom tanks.
Mhm.
Then it's a good solution. You see it a lot in the wastewater business, and a lot of polyethylene tanks are in use nowadays. So that's a good solution. But as soon as you get other kind of chemicals to store, or at higher temperatures, or you want to have bigger volumes, then yeah, you have to go for you have to choose for another material.
Okay. Let your customer and audience decide based on that. So I have two more questions, and if there are no more questions from audience, we can conclude today's session. One is technical, one is not technical. When it comes to dual laminate equipment, is a good alternative to is it a good alternative to expensive Hastel alloy or titanium? If yes, what is your experience?
Yes, that's we have yeah. If you look to, for example, for piping material, it is for sure. Especially if you compare it to Hastelloy. But what we see is, for example, for sometimes, and it's a combination of chlorides, but then we talk about storage tanks who are much bigger in diameter. For example, what started at 6 diameter and goes to whatever 10, 11, 12 meter diameter. Then it's and if you talk about field fab or particle field fab, then sometimes duplex materials can also be an option. If there are chlorides in the for example in the wastewater or in the liquid, but for the rest, normally, yeah, our material is much more economic if you compare it to Hastelloys.
All right, interesting. Thank you. I understand that all this is produced in India, and of course, Europe is a big market with a lot of standards. How does Grading ensure that it is as per the European standard? Do you have any labs, or you do have some certification methods?
Well, actually, they have to, because if you want to deliver to Europe, and I think Europe is one of the toughest markets in the world. If you look to the specifications and the expectations of the clients. Well, they have a huge quality control department. They can do all the tests by themselves, and of course, yeah, we can also use a local Nobo, or a Nobo from Europe. Okay, it's of course more expensive, but normally we can also work with local Nobos.
Perfect. Thank you. So yeah, no, I think it's a very interesting conversation. We can go on for another 30 minutes, 1 hour. So of course we will total 1 hour, and then we have covered so many questions. I feel that audience are enjoying it. There are still some of them are listening to us. Dear professionals, if you could hear me, I'm sure you could hear me. Let me know how do you feel. If there are any more questions, feel free to put it on the chat. And until then, I would like to ask very last questions, Yana. What is that you haven't covered in today's webinar, but you would like to mention to all these industry professionals?
Well, I think that's the most important thing. If you are familiar with the material, then you know that you have that's what I mentioned before, that you have to do the right design, the right material choice, and of course the right production facility and quality control. But that is really important if you want to. If you've never worked with this material before, I think it's good to have to get in touch with the right people for the right advice, so that you are very happy with your fiberglass products in the future.
Perfect. Thank you. And with this, we can conclude, unless our speaker Yanano has more things to add.
No, thank you.
I would like to thank everybody for your time, and please feel free to visit our website www.greytech.nl or connect Yanano on info@greytech.nl, or also Jan Ano has his email address that we can share with you again, or you can connect us on LinkedIn, where we really put a lot of technical things as well in between. And last but not least, Yanano, thank you for all the explanation and discussions. If some of you would like to connect with him on LinkedIn, there was a QR code. Please feel free, and let's be in touch with Greytech. Thank you for your time, and we would love to see you again in the future webinars.
Thank you all for attending.